Hello guys, welcome back. So in the today's session we are going to see about the transition from IP version v4 to the IP version v6, right? So in the previous classes as we discussed that, the length of the IPv4 is nothing but the 32-bit length. It means that we will be getting the 2 power 32 nothing but the 4 billion unique IP address, around the 4 billion, which we can use assign to the end device in the network. Now problem is that in real time we have the more number of the end devices compared to the 4 billion IP address. So for that we have implemented something called as the classless, right? So classless IP address mechanism. Then we implemented something called as the private IP address mechanism, right? So after implementing all these techniques also, still the available IP address are the much lesser than the number of system in the world, right? So now what they have invented means they have moved to the IPv6 version 6. So v4 is nothing but the 32-bit length, so v6 is nothing but the 128-bit length, right? So it means that if in case of IPv4 we will be getting the 2 power 32 number of the unique IP address, where in IPv6 we will be getting the 2 power 128 number of the unique IP address. So which is a huge amount of the IP address we will be getting, so that problem of the IPv4 is solved, right? Now question is that, right, so the moment if you have the completely we are switching to the IPv6, then what about the IPv4? So what I'm trying to say here is that, so if you are purchasing the new device, whatever there is a system, it may be IoT device, whatever it may be support the IPv6, right? But still the device whichever we purchased already, the most of devices they works only based on the IPv4, right? So they don't know anything about the IPv6. It means that completely on one day we cannot able to migrate to IPv6 completely, right? So it is the process, right? So because of the huge number of the system on the internet, the transition from changes from the IPv4 to the IP6 cannot happen suddenly, right? So for that, right, so what we are going to do is we are going to propose some methodologies, that is what we called as the transition strategies, right? So it means that it will take a considerable amount of the time before every system in the internet can move from the IPv4 to the IP6, right? So the transition must be smooth to prevent any problem between IPv4 and IPv6 system, right? So for that, for smooth transition, there are three strategies have been implemented to switch from the IPv4 to the IPv6. Remember that. So suddenly we cannot able to migrate completely to the IPv6. Now we are going to study the what are the different transition strategies in order to, right, so from switching from IPv4 to the IPv6 completely. One proposed algorithm or transition strategy is the dual stack method. Second one is the tunneling operation. Third one is the header translation operation. We will see that when we require the dual stack algorithm, when we require the tunneling operation as well as the header translation operation. So we are going to discuss these three transition strategies in today's class. Now what is the first one? The first one is nothing but the dual stack algorithm. So what is the meaning of this one? See that, so here it is recommended that all the host is nothing but all the system before migrating completely to the version 6, nothing but the IPv6, have a dual stack protocol, right? So see that the meaning of dual stack is the station or device, or it may be whatever it may be host, that must contain or run with the IPv4 as well as the IPv6 protocol simultaneously until all the internet uses the IPv6 algorithm. As we know that if you are taking this transport layer and remaining layers are the application layer, then here we will be having the L2 layers, right? So physical topology. So in between we have the what? Layer 3 is nothing but the network layer, right? So network layer only we will be having the IP address mechanism, right? So we have the two, one is IPv4 version, another one is the IPv6 version. So before completely migrating to the IPv6, right, so as time being what we have to do is all the hosts are nothing but the system, they have to maintain the dual stack algorithm. So it means that it should support the both IPv4 as well as the IPv6, right? So this is what we called as the dual stack operation. Suppose for example, see whichever the newer system we will be having something. So let me open this. This is one of my computer, right? So the moment if I open this computer, see that you can find it. So this is IPv4 addressing mechanism. So this is also support the IPv6. See that IPv6 address also we can able to give. Suppose if something system they want to communicate with only IPv4, then we can use this algorithm. or if system want to communicate with only IPv6, then we can use this one. So that is what we called as the dual stack operation. Now question is that we have the two right, one is IPv4 as well as the IPv6, right? Now how to find when to use IPv4 and when to use IPv6? It may be suppose in your system we have the support as the IPv4 as well as the IPv6, right? But if you are communicating with the another system, right, we don't know whether it is running with IPv4 or it is running with IPv6. Then another possibility is it may also running with the dual stack operation. Suppose for example if it is running with only IPv4, suppose for example old device or old system, it is having only IPv4. Now see that I have IPv4 as well as the IPv6, right? Now if you want to communicate with only by using what? IPv4 before completely moving in terms of the IPv6. Now how do I find out whether I need to execute this one IPv4 or IPv6 at the transmitter side? So at what possibility you will be getting this one is the moment if you know what it is using either IPv4 or IPv6 of the destination system. After knowing only we can able to send the particular IPv4 or IPv6, right? Now see, read this statement. To determine which version to be used when sending a packet to the destination, the source host queries the DNS. And suppose for example if you have the system A, as we discussed in the initial classes, system B. So in your browser what you are going to do is you are typing something called as the google.com, right? Suppose for example here it is a Google database, right? So if you want to get some information in the Google database, just you are typing the google.com. It means that connection will be established from the system A to Google server. But internally what I told, if you want to communicate one system to the another system, so this will be having the some IP address, this will be having the some IP address, right? Now see that, but instead of entering the IP address, we are entering the naming convention. So but the moment you are entering the naming convention by using of the DNS domain name system, it will automatically convert this naming in conversion in terms of the IP addresses. Now see here the point, we need to know that what is the receiver, right, which is running, whether it is IPv4 IPv6, right? The moment if you queries the DNS, we will be giving some result, right? So if the result is in terms of the IPv4, then I can send from my source machine only IPv4 packet. If the DNS query is something, if we get IPv6 address, then we will be using the IPv6 mechanism, right? See that if DNS returns an IPv4 address, the source host sends an IPv4 packet, or if the DNS returns an IPv6 address, the source host sends an IPv6 packet. Now if you don't understand, first what we are going to do is something, for example, let me open my command prompt so that you will understand. Correct. So for example, see that I have some command ns lookup something, if I am typing this google.com or whatever it may be. Now see that for understanding purpose only we are using google.com, right? As a human being we cannot remember the IP address, right? But internally that naming convention will be converted into what? IP address. Now see that, suppose for example it is supporting dual stack. Suppose for example, so after typing this DNS query ns lookup command followed by the website, so see that what is the address we are getting, suppose this one. So for 32-bit address, right? So this is nothing but the IPv4 algorithm. Suppose if there is no IPv6, suppose for example if you are typing some other one, some may have the only IPv4, some may have the IPv6 also, right? Something like this. Now see that, so here we have only IPv4, right? It means that some website or whatever it may be, so it is retrieving only the IPv4 address. It means that it don't know anything about the IPv6. Now after doing this command, right, we are inquiring the DNS query, right? Now what is the address it is written? IPv4. It means that it will go with the IPv4, right? So this is what we called as the dual stack operation. It means that it has to have the both IPv4 stack as well as the IPv6 stack, as we shown this one, IPv4 as well as the IPv6, right? One day we cannot able to completely migrate to IPv6, right? So one way is that using the dual stack. So if it is IPv4 required, we can use the IPv4, right? By querying the DNS we can get the what is the IP address of the server, so that we can able to perform the IPv4 or IPv6 address mechanism, right? So this is the first strategy, right? Before completely transition from the IPv4 to the IPv6. Next strategy is nothing but the tunneling operation. We will see what is the meaning of tunneling, in which case we required the tunneling operation. Now we will see that what is the meaning of the tunneling operation. So tunneling is a kind of strategy used in two computers using IPv6. It means that if your source machine as well as the destination machine, if it is using the IPv6 version, then we are using something like this. For example, you consider here the source machine having the IPv6 as well as the destination machine also IPv6 only. But the moment when packet is being routed from the source machine to the destination machine, there will be a number of the intermediate devices, as we know that. Now what is the problem we are facing, how we are going to solve by using the tunneling method, we are going to discuss here, right? So when two computers using the IPv6 want to communicate with each other, and the packet must pass through the region that uses the IPv4. So what is the meaning of this one is, if the system A, system B, it wants to communicate with one to another by using of the IPv6 addressing mechanism. But if you want to reach the packet from the source to the destination, there are n number of intermediate devices will be there, right? We can't assure that all the intermediate devices or whatever it may be, it is running with only IPv6 algorithm. Some may use the IPv4, some might be using the IPv6, right? So now what we have to do is, now this IPv6 packet, we need to pass through the IPv4 region. It means that suppose these are working with the IPv4 operation only, but if you're sending IPv6, it won't consider, right? Because it is working based on what? IPv4 algorithm, right? So now what we have to do is, somehow this IPv6 packet must pass through the region that uses the IPv4, right? So to pass this region, right, so the packet must have the IPv4 address. See, it will understand only IPv4, right? Even though if you have IPv6, that somehow it should be translated means not in terms of completely converting, somehow we are so that, see that here you will be understanding. So the IPv6 packet is encapsulated in the IPv4 packet when it enters in the region. It means that, now see that, so this is IPv6 header payload. The moment it going to here, we are performing the encapsulation operation, right? So now what we have to do is, this IPv6 packet, right, so we need to take inside of the IPv4, right? We are not completely changing the IPv6 in terms of the IPv4. Remember, that is an important point. So somehow we are encapsulating the IPv6 packet inside of the IPv4. So that is what we called as the encapsulation. Encapsulation means the process of adding the additional information to the existing information is called as the encapsulation process. Now see that what is happening. The moment when it is passes to the IPv4 region, this IPv6 as well as the header as well as the payload encapsulated into what? IPv4 header. Now if you understand what will be happen means, it will treat this one as the IPv4 only, right? So just for moving the data from one intermediate device to the another device. So the moment when it reaches to here, now what we have to do? So finally it should be only IPv6, right? But here we have the IPv4 encapsulation, right? Extra information. Now here what we have to do exactly, we have to perform the decapsulation operation. Now see that what will be happen. The moment it comes to the receiver, that extra information we are removing, right? So it means that we are performing the decapsulation operation when it is exist on the IPv4 region, right? Now how to find out whether it is we are performing the tunneling operation means, so for everything we have something called as the protocol. If the protocol value is set to be 41, right, so now it, right, to make it is clear that IPv4 packet is carrying an IPv6 packet as a data, so then we need to set the protocol is the 41, so that it will automatically understand that IPv6 packet is carried through inside of the IPv4. Remember, this is very important point. We are not converting IPv6 packet completely in terms of the IPv4, right? So we are encapsulating IPv6 packet inside of the IPv4. When it leaves the IPv4 region, we are removing the IPv4 so that you will be getting the same IPv6 only. This is important point to be remember. This is one kind of the strategy, right? So then next final strategy is what? Fine. The final strategy is the header translation strategy. So what is the meaning of this one, and when we are using the header translation strategy means, Suppose you assume that, right? So after a few years, like maybe 2040 or somewhere around, so almost all 95% or 96% of the devices are they completely migrated to the IP6. Only something around 5% are still using the IPv4. If it means that in 2023 most of the people are using iPhone, right? iPhone 15 something, right? So still some people they are using the iPhone 5 or iPhone 6, right? So still, so in 2030 also maybe some of the people they might be using iPhone 5 or 6 only, right? So we cannot stop them to make a call from one person to the another person. So these kind of situations. So what is the situation here is that if almost all devices they turned into the IPv6 after a few years, then still some of the system they will be using only IPv4 algorithm, right? So now in that case what we are going to use is we are using something called as the header translation strategy, right? Now see that when it is required means header translation is necessary when the majority of the internet has moved to the IPv6 but still some of the system still uses the IPv4. In that case we require the header translation, right? We will see what is the real meaning of the header translation, right? So the sender wants to use IPv6 but the receiver does not know or does not understand anything about the IPv6, right? Now see that if you are making the tunneling means what? Tunneling means carrying the IPv6, right? IPv6 packets inside of the IPv4. It is something like cover, right? It is only carrying the IPv6 as it is, right? But if you are doing the tunneling operation, now it is not meaning. It requires only IPv4 but it does not know anything about the IPv6, right? So now tunneling does not work in this situation because the packet must be in the IPv4 format. So tunneling used to send the one different kind of packet inside of the another different kind of the format. But here my receiver will understand only IPv4 means I cannot perform the tunneling operation, right? So format to be understood by the receiver. In this case, the header format must be totally changed through the header translation, right? So the header of the IPv6 packet is converted into the IPv4 header. So header translation means, suppose for example you have the source mission or destination mission. Suppose 95% of the system is migrated to only IPv6. Still some 5% system are using the still IPv4 addressing mechanism. Now see that the moment you are sending this packet, it will not understand anything about the IPv6, right? Now what we have to do, but it will know only IPv6. Now what we have to do is somehow we need to convert this IPv6 packet in terms of the IPv4 packet. So this is what we called as the header translation. Converting from IPv4 to the IPv6 to the IPv4 is called as the header translation. So see that the most of the things which are using the IPv6 region, but still few of the devices it is using the IPv4 host, something like 2040 somewhere around. Right now here what we have to do is we need to completely convert this one IPv6 in terms of the IPv4. That is what we called as the header translation strategy, right? So this is important point. Tunneling can be used to carry IPv6 inside of the IPv4. It means that it is not completely convert IPv4 in terms of the IP6, right? So that point you have to understand, right? So what are the three strategies we have discussed in this today's class? So to transition from completely from IPv4 to IPv6, so as time being these three strategies are implemented. One is dual stack algorithm, another one is tunneling operation, another one is the header translation operation, right? So hope you understand guys. Thank you very much. If you like my video, please subscribe. Thank you.